Right, so in lieu of grading all of the submissions for this one individually, we figured that it would be the fastest way to get feedback to you if we instead just sort of provided a walkthrough for how to approach this problem. So this is the practice quiz 3 uh, or practice quiz 3C. So this is the assignment that you can submit for points. We're going to be providing this then as a resource to sort of show an approach as to how you might go about sort of thinking through one of these problems. So in any case, in order to get started, we have a starter part file that we're going to want to get downloaded. Here I have it open in SOLIDWORKS. And we also have a list of features and modifications that we're going to be making. So it says in the instructions, we're going to be saving it to our standard file naming format. And it says that we're going to be adding the features according to the drawing, and they're listed in a random order. So very first up at the top, we're warned that there is going to be a shell feature in this model. So that tells us that we need to be careful about what happens before the shell and what happens after. We also have a hole, specifically using the hole wizard feature. We've got a fillet, a rib, a semicircular cut that we can sort of see on this auxiliary view here, an equation. So that's the height equals piston diameter minus 12, and that is going to be affecting these two dimensions here. And we're going to be creating a second configuration where the hole is suppressed and the piston diameter is set to 90 instead of the 84 that is shown in the drawing. After that, we're going to save it, upload to Canvas, all that good stuff. So in the standard exam, you will have 50 minutes to go through this entire problem start to finish. We'll see how long this takes us, but probably considerably less since I know what the answer is, which is always fun. But anyway, you can expect something probably a little easier than this on the actual exam itself. But in any case, I mentioned earlier that we have a shell, so that means that we're going to need to consider what happens before and after. So the main thing that we want to look for is, are there any aspects that are going to need to occur before the shell? And things to look for would usually be thickness in material that is requiring that something outside of the geometry is modifying, or something on the outside of the geometry is modifying the inside. And one trick we really like to use for these is fillet placement. So we can see in our section view that's taking the place of our front view, this is section A, so that's coming from our top view up here, that we have these rounded corners on the inside of our object to match up with the rounded ones on the outside. So that tells me that these fillets are going to need to occur before the shell feature. Another thing to keep an eye out for is holes. So if a hole is done before the shell, then the entire pathway of the hole is going to have a thickness associated with it. So we can see continuing on in that front view that we have hatched sort of solid material that our section is cutting through on the top and bottom of our hole as that passes through our object. So because we see that thickness, the hole needs to happen before the shell. If the hole happens after the shell, then we're going to end up with a cutout on the right side and a cutout on the left side, but it will just be empty open space in the middle and we won't have that tube acting as a guide. Let's see, other than that, we have the rib feature. We can see that we've got sort of this plus in the middle of our cylinder, and based on our section views, so section AA, where we can see that we have this slightly differently hatched pattern there at the top and a matching differently hatched pattern in the top of section B, that tells us that these little slats are our ribs. So that's going to need to occur after the shell because we won't be able to get access to the inside of our object before the shell feature happens. Similarly, we have the little cutout on the top of our object. So this one, we can see that it cuts into our object, but the shell thickness sort of remains consistent before and after, but it sort of changes in thickness within that cut. So that tells me that this cut is going to need to happen after the shell, because if it happens before the shell, then it's going to have material sort of following along on the outside. We'll have an indent on the inside. One other thing I want to bring up about this cut is that it is a little ambiguous as to whether or not you would want to do this as a cut extrude using some reference plane or a cut revolve, which we could just do on the top face. In this case, we would know that it has to be an extrude because if there's a revolve, we would actually see two sort of arcs on the inside, one from where it starts on the top surface and then another one from where it ends on that flat surface on the inside. So that second one would be a hidden line from our top view. So because this curvature remains consistent, that tells us that it needs to be a cut extrude as it goes down. All right, so you can see we spent a little bit of time sort of thinking about what all we're looking at before we started. I would definitely recommend you reserve the first couple of minutes of your own exam to go through, think through your process. And that way, when you actually get into the process of doing your modeling, you have a plan of attack for how it is that you're going to approach the problem. So, all that said, let's get into it. And let's begin with that fillet because, hey, it's the easy one and we already know what we're doing. So 2x radius 3, pop open our fillet feature, can plug in 3 as our radius, and we want this edge here and the corresponding edge on the other side. Check mark. It's one down. We also know the hole wizard needs to happen before the shell, so we're going to do that one next. We're told about it in our right view. We can see it's 15 units down sort of from that lip, and it is fairly centered. So what I would recommend with the hole wizard feature is usually you want to select the surface first, then you can go up to your features tab and select the hole wizard. From here, we've got our giant menu. We want to make sure that the standard that we're using, ANSI matches the units. And other than that, we want to make sure that our hole type matches the one we're given. So we have that V shape on our hole callout. So that tells us we want the countersink option. So we've got countersink selected. Scrolling down using the scroll bar. I do not recommend using the scroll wheel when you're working with the hole wizard because if your mouse accidentally hovers over one of these boxes, it will just completely screw everything up. So in any case, say diameter 16 for the through hole, so we'll plug in 16 for our first box. Then for the near side feature, it's got a diameter of 20 at 82 degrees. So this one plugs in 20, and we have 82 as our angle. Our end condition is defined by the second bit on the top row of our callout. So that's through all, so that could mean that it's either through all, up to next, or up to surface. In this case, however, it pretty obviously just goes through the entire object, so we'll leave that as is. Next up, we're going to actually get to our position. So I'm going to open the position tab, and because we had that surface selected, our position is going to auto open a sketch on that face. I'm going to go Control 8 so we can see things a little better. And we want it right in the middle. So I'll just place mine off to the side so we can go about defining it manually. Hit Escape to deselect our tool. And then we can use our Shift key combined with the origin and the point that we generated and apply a vertical relation. There we go. That centers it for us. We can use our smart dimension to define the distance from that top edge there to our point as 15 units. Cool. So all that said, we've got our hole position, we've got our text callout, we'll hit our check mark. We can see now that we have this hole that goes all the way through our object. Quick sanity check, we're gonna hit Control 7. We should see that the hole features match up with what we've got in our isometric. Cool. All right, next up we've got our shell feature. So for this, we'll go to our shell, and we can see that our shell thickness, or our wall thickness, is defined in the note as being 6 units. So we'll plug in 6 as our parameter. I'm going to set it to show preview so that we can see what we're doing. And additionally, in this one, we get a bottom view, and we can see into the object clearly well, as clearly as they can with that giant cylinder sort of stuck in the way. But we can see into the object and we see the ribs without them all being represented as hidden geometry. And also importantly, in section B, we can see that it's open on the bottom. So that tells us that we do want to remove a surface, which is going to be this bottom face here. So we'll select that curved sort of spherical surface as our faces to remove, hit our check mark, and we are good to go. Looks pretty good so far. So there's our shell, check. Let's do the rib next. So we can see in section B that our rib is starting 20 units down from the top surface of our object. So if we're lucky, we already have a plane there, but alas, we are not. So we're going to have to make one ourselves. So in this case, we'll go to our reference geometry, select a plane, and this plane is going to be defined as an offset from that top surface. So we'll select the top face there. We can plug in our 20 offset, and we need it to start down. So I'm going to flip our offset to get the plane in the right place. Check mark. Now we can just draw in our rib sketch. So this one's just going to be a nice simple plus on that surface. Looks like it goes right through the middle. And fortunately for us, when we open our sketch, Control 8, we can see that our origin is already there for us. So I'm just going to draw in our plus. You can double click to stop a line while you're drawing it if you would like. Saves a little bit of time. And let's see, you can see that we've got a point. It's getting a little messy because we have that other sketch in the way. But for these ones, we just need a horizontal line that passes through our origin and a vertical line that passes through our origin. And once we've got those two, I'm actually just going to go into our revolve. We can right click and hide that other sketch. There we go. So we've got those two. They pass through the right points. The end points of our rib sketches are allowed to be underdefined, but the lines themselves had better be fully defined. So we need to leave those as is, but it's okay that we have our points as blue. So we've got a sketch. I'll pop back over to the Features tab. We'll go to our rib, and we can also see in our bottom view that we have a rib thickness of 2 units. All right, new problem. Our arrow is pointing the wrong way. So we can see in our drawing that we have the material going up. So we need the arrow pointing upwards. So I'm going to check our flip material side, hit our check mark, and that fills in our rib for us. Nice. All right, let's see. Next up, we've got that cut extrude. So we can see the dimensions for it in true size and shape in the top view, or in the auxiliary view. So that tells us that we need a reference plane at an angle first. And then once we have that reference plane, we can go about creating our sketches and doing the extrude from that reference plane out so that we can keep that line perpendicular as it goes outwards. All right, and here is where I realized that I did make a slight mistake. We actually do want to keep this sketch around for a little bit longer because that top edge of it acts as an excellent axis for our reference plane. So I'm going to right click sketch 1, we'll set it to show once again, and then we're going to go and create a new reference plane. And we can see that it is defined as being 10 degrees down and about that horizontal line. So we'll select that line there. Whoops, we want to select the surface, and then we can set an angle at 10 degrees. All right. So we can see that in the isometric view, the plane sort of goes down and inwards. So let's try flipping our offset. There we go. Control 7. This plane is not in the right spot per se, but it is at the right inclination and everything. And because the plane is infinite, its exact location doesn't matter. So we are actually on the right track here. We'll hit our check mark, right click, create a new plane or a new sketch on this reference plane that we've just created. Control 8 to bring us normal to. And for this one, we are going to want here, let's do an arc and a line. So In order to clean things up a little bit more, I'm just going to set this back to shaded with edges as our display style. And I'm going to hide that sketch again. There we go. Then from here, we can see that we've got our straight line for the arc sort of passes through the origin. So we'll set that like that. Then we can draw in our 3-point arc. You could do this as a center point arc as well. Doesn't really matter. And we want it coincident with the line. So what we know about it is that the center of this arc is offset 8 units from our origin. So using our smart dimension, from the origin to the center of the arc, plug in our 8 units. And then the circle has a diameter of 60. So this is going to default to give us a radius. So we'll just place that dimension down. Then we can go to the liters tab while our dimensions bar is still up and set it to diameter. There we go. Then we can just plug in our 60 units. And now we have our sketch all set up. Control 7 to double check. Looks like it's in the right spot. Awesome. Then features, extrude cut. And we want it flipped so it's going out. And we don't actually have a number telling us how far it goes, so we're just going to guess through all and see what happens. Nice. That looks pretty spot on. Cool. So we've got 2 more things to do. Very important. There is going to be something asking you to create an equation. There probably is going to be something asking you to create a configuration. So we need to make sure that we include those because otherwise we're leaving quite a few points on the table. So let's start with the equation. The first thing that you want to do with equations is show all of the dimensions. So for that, we're going to right click on the annotations and select display annotations. Those should have, all right. But cool. So we can see that we've got our height dimension is this 63 here, and we should have a piston diameter somewhere. Oh, there it is. It's hiding in the bottom. There we go. So we've got our height, we've got our piston diameter. We want to set the height equal to piston diameter minus 21. So I'm going to double click on the number. We want to make sure that we get this modify box. There are other methods to do this, of course. If you want to watch the pre-lab video for pre-lab 8, that also covers additional techniques, but then you can just type equals, and then you can click on your dimension that you want it to be related to. In this case, it's the piston diameter, then minus 21. Check mark. That's going to add our little red sigma next to the dimension and set it up so that now as the diameter changes, this height should also change. There's our equation. Finally, we've got our second configuration. We want the hole suppressed and the piston diameter set to 90. So whenever you're making configurations, first step, you're going to go to the configurations tab, right click your name all the way at the top and select add configuration. We're just going to call this second config. Double click to see, make sure we do have 2 separate configurations. However, currently everything's the same across both of them. So now we need to make some changes. So for our second configuration, our diameter needs to become 90. So we'll right click on our diameter, and then there is a configure dimension option. This is the most reliable way to ensure that changes are made across configurations and not just accidentally setting it. So, oh, well, now it's 90 in both versions. So we'll go to configure dimension. We choose our second config option from our table. We plug in 90. Hit OK. Now we can see that the second config is slightly bigger, and also our equation is driving the height to be slightly larger. So that tells us the equation is functioning as intended. And the other thing that we need to set is a suppression state for the hole wizard. So we're going to find the hole wizard in our design tree, right click, same song and dance. We're going to go to configure feature. We want to check it that is suppressed in our second config. So we'll hit OK. Double check our work so we can see we have the hole and we've got the 84 in our default. And then in the second configuration, we do not have the hole. You can see this time we don't have anything on the inside either. And we also have the diameter of 90. So at this point, save your file, make sure you got the naming convention correct. If I was smart, I would have set the naming convention at the start and also been saving after every feature or so. But I am working on my own install and I trust my computer a good bit, so it has not betrayed me at this time. But anyway, that takes care of that. Go through your file submission and yeah, should be good. So just remember when you're working on the actual quiz itself, deep breaths. You do know everything that you need to know in order to be successful. Just make sure that you go through, you do the practice, you check over the prior assignments, and make sure that you ask questions for the exam day because we probably won't be able to answer them during. So, in case, thank you very much for watching slash listening slash having this open in a background tab somewhere. Hopefully this was helpful, and otherwise, best of luck with the exam. See you there. Bye.